Fiske Planetarium at the University of Colorado Boulder. Welcome to Explorations, the series that takes a look into NASA's diverse projects and the people who make them happen.
Hello, my name is Claire. I recently graduated from the University of Colorado in Boulder, where I worked on a catalog of double stars, and now I'm at Harvard's Center for Astrophysics, where I've been helping with a massive survey of distant galaxies. I like working with lots of data, which is fantastic because large-scale surveys are a huge part of modern astronomy. So today I'm going to tell you just a little bit about a NASA survey happening right now that I am really excited about. Orbiting high above Earth, a lone telescope is searching for small shadows passing in front of stars. Shadows that are the key to discovering hundreds of new worlds. Our sun is not the only star with planets orbiting around it. Each one of the stars in our sky could have planets around them too. We call these distant worlds exoplanets. Finding exoplanets is tricky though. Seeing a small, faint planet next to a big, bright star is like looking for a firefly next to a spotlight, when both are 1,000 miles away. So astronomers use light from the star itself. Here's how it works. This is a measurement of the star's brightness. As soon as a planet transits in front of the star, it blocks some of the star's light, and the star appears to dim slightly. The planet continues past, and the star goes back to its original brightness. We have found hundreds of planets using this transit method, but have only surveyed a small fraction of stars. NASA is on the hunt for more. The Transiting Exoplanet Survey Satellite, or TESS, is currently looking all over the sky at 200,000 nearby stars. Its 4 cameras allow it to view a large portion of the sky, and it takes an image every half hour. Unlike NASA's previous planet hunting mission, Kepler, this satellite will look all over the sky at stars that are relatively close to Earth. Since these nearby stars are easier to study, TESS will find hundreds of new exoplanets that are perfect for scientists to take a closer look at. But TESS can do much more than just find planets. Every exoplanet is unique. There are small, rocky ones like Earth and Mars, gas giants bigger than Jupiter, and even puffy planets with the density of cotton candy. All of these planet characteristics affect its light curve. For instance, a larger planet will block more light and create a deeper dip, and a planet very close to its star will orbit faster and create more frequent dips. Scientists can even look for particular patterns in this curve to tell if a planet has an atmosphere and how thick it is. Then future observations can tell us what the atmosphere is made of and even if it contains potential traces of life. Astronomers estimate that, on average, there's at least one planet for every star in our galaxy. This means there are billions of worlds out there just waiting to be discovered. Many are similar to Earth, and some may even host life. TESS can help us figure out just how lonely the universe is, all from a tiny shadow created by a small bit of rock passing in front of a distant star.
My name is Berta-Thompson. I'm a professor of astronomy at the University of Colorado Boulder. I study exoplanets with TESS. We use data from these telescopes to look for new planets around new stars. And I'm doing this because I want to understand how planets work. We've studied Earth a lot, but actually to understand Earth better and to understand the other planets in our solar system better, it would really help to have other examples of different kinds of planets that we can study so we see how they respond to different environments. So TESS is really, really great because it's a telescope that allows us to find some of the closest planets in the galaxy. They're still really, really far away, but they're close enough that we can point other big telescopes at these planets, and we can study them in detail and learn quite a bit about them. One of my favorite observations to make of an exoplanet is to watch as it passes in front of its star and measure the color of its sunset. This teaches us about the composition of its atmosphere and how it's evolved and what it's made of. This is such a cool observation to make, both for important science reasons and also because When I was a little kid, I remember going out and sitting and watching the sunset with my parents. They're both artists. I didn't know I wanted to be a scientist. When I was growing up, we really focused a lot on our imagination and creativity. And so I spent a lot of time thinking about what sunset would look like on some weird alien world. And now as an astronomer, I get to go out and point telescopes at other planets and study sunsets on weird alien worlds. It's a pretty fun job.
On behalf of NASA and Fiske Planetarium at the University of Colorado Boulder, thank you for joining us for this episode of Explorations.